What if I told you that right now, today, you can pull up a GitHub repo, order some parts, and build a full-size humanoid robot in your garage? No wait list, no $200,000 price tag. This is Asimov version 1. It's an open source humanoid robot from Menlo Research. It's about 1.2 meters tall or 4 feet. Perfect size for your AI companion if you needed a physical body for it. And weighs about 35 kilograms, has 25 actuated degrees of freedom, and every single file you need to build one is sitting on GitHub, free to download right now, as we speak. And link for that will be in the description. And so today I'm going to do a full walkthrough of that repo. I'm going to check out the website. We're going to look at the bill of materials and see what kind of parts we need for this robot coming up. So if you like this content, go ahead and like and subscribe, or just subscribe at least. That'll help me produce more content. Alright, let's check out the Asimov version 1 robot. And I used Claude Code to do some research about this robot before I started recording this, so let's see what it said here. Asimov is built by Menlo Research, an applied R&D lab focused on humanoid robotics. Now, as legend has it, their team was running a Unitree G1 robot when the knee failed. 2 months of downtime waiting on proprietary repairs. Now that frustration drove them to redesign the whole thing from scratch in months for under $30,000 in R&D, apparently. Wow. So the philosophy is simple. Open hardware, open supply chain. You can build it, train it, mod it, and contribute back. And the name is a nod to Isaac Asimov, the sci-fi author who wrote the 3 Laws of Robotics. And it's no accident. Safety constraints and operational telemetry are baked into the hardware layer. Alright, now let's get into the repo. And right away you'll notice this is dual licensed. So we have a hardware license and a software license. And so apparently any modifications that we make, they want us to remain open source, or they must stay open source, is what it says apparently. So we should respect the spirit of that. Alright, so the repo has 4 main folders. Let's scroll up. So we got electrical, mechanical, then we got a sim model, and we got our assets. So the main one you really want to focus on, well, to start off with, you want to focus on, you can check out the sim model. If you have the hardware for it, you can run that on your PC or whatever you got, your Mac. You can run that on your workstation, and you can simulate the robot, apparently. So they included some meshes, so that's good. Yep, meshes of the entire robot. And then, let's go back to sim model. Okay, that's nice. 28 link meshes, STLs, okay. But if you really want to build this in real life, you want to jump over to the mechanical folder here. And here's where it's going to have a breakdown, subassemblies, and they're numbered. Now at first, the numbers might seem a little weird. It goes from 1 to 700. But if you look at this here, they actually broke down the code for how the parts are laid out, or the numbers for each part. So rather than saying, left hip or right hip or left foot or right foot or whatever, it's just got a number code. And so it actually makes more sense once you look at this diagram. This is on their GitHub. So if you drill into the you can see what they're talking about right here. They're talking about. Alright, so if we go into 100 fabrication, you're going to see ALU 7075, or you're going to see these different numbers. But according to the diagram, you could figure out what that actually means. Let's see if we go back to the diagram. So that was in 100. So that was for the torso. And then so some of these parts need to be CNC machined with aluminum 7075 is their recommendation. I'm assuming that's lightweight, but also strong enough to support the motors. And then some of it can actually be 3D printed. I believe most of the robot is actually 3D printed, but the motor mounts need to be CNC machined for maximum strength. Because 3D printing, it's not that strong. It's good for some stuff, but for a robot you need a little more strength around the joints, especially if you're using motors to move the joints. So as you can see right here, like the shoulders, that's aluminum. And then the rest of it, this looks like, it's all 3D printed out of whatever material. You can make it whatever color as well if you're 3D printing it. You could do a multicolored robot, or you could do it all black, or however you like. And it looks like the camera's right there in the chest. I think it'd make more sense to put it in the face, but I guess the chest works as well. I don't know. Okay, so let's move on from that. Oh, they also have a YouTube channel I should probably point out. They got a bunch of shorts on here, and it looks like they started with the legs. If you scroll down all the way, they started by building the legs. They got a bunch of shorts, and then eventually they they created the rest of the robot. And honestly, I'd probably make some modifications in the hip area, if you know what I'm saying. Alright, moving on. Here's the website, the manual, and the BOM. Estimated cost, I should probably break it to you, $22,000 according to them. Wowzers, and that's not including a few things. Actually, let's see. If we jump over here to the GitHub, alright. So here it shows you what's included and what's not included in their DIY kit. So if you order the kit from them that's already assembled, instead of sourcing everything yourself and manufacturing everything yourself, so they're not going to include the tool, or, well, obviously probably not the tools, but they're not going to include the hands, which is pretty important. If I have a robot, I've got a few uses for the hands, for sure. They're not going to include the LiDAR or the 360-degree camera. And they're not going to include the battery, which might be the most important part of this whole project. I mean, if you don't have a battery, how are you going to move this thing around? So that's kind of a bit of an issue. So you have to source your own battery if you were to build this thing. But I mean, most of the work is already done here. I mean, they've got electrical wiring, schematics, PCB files, locomotion policy. Looks like, oh, these are coming soon, I see. Well, they've got an electrical wiring harness. I believe I saw electrical up here. Yeah, there's an electrical folder. And there's also a Discord. There's a whole community behind this, so you can check that out as well. I'm sure someone on there will probably answer some questions. Let's take a look at the bill of materials. All right. So I requested this. I went on their Asimov manual website and requested this. And looks like you need a bunch of screws. All different sorts of sizes of screws. Let's see. And then these are the motors they're recommending right here. And that's actually maybe one of the hardest parts of building a robot is the motors, because Motors are often designed for a very specific task, and you know, robotics is, well, they're usually very heavy also and loud. Most motors are pretty heavy and loud, and the power usually increases with the weight. So the more powerful it is, the heavier it is, and then you need a stronger motor to carry it, and then everything around it needs to be stronger, and so it just gets heavier and heavier. So anyhow, and you need a bunch of wire, uh, then some other wires, some different connectors, some Molex pin housings, and USB cords. And then apparently you need a Raspberry Pi 5 is what this whole thing is recommending you run it on. And then a couple of different speakers and a USB camera. So basic camera. Um, and then it does looks like they include some boards, an edge board, motion control board, network board, and a power distribution board. So that'll save you some work, you know. You can connect all your motors hopefully to this, and then just plug it into the Raspberry Pi, and hopefully just write some code and get it moving. And then it looks like in their videos they have it on a crane, and they actually in their GitHub they actually have a crane, open crane. Let me see. Let me jump over here. Show you what I'm talking about. So if you want to build your own crane, let me go to the repositories. Open crane. Here's what I'm talking about. So they have a little. Oh, here's the actual picture. There we go. You can build your own crane, and here's the files for that. So that's what I'm trying to say. So that's kind of cool. I'd probably just lay this robot on the floor, and my first task would be getting the robot to push itself up off the floor and stand on its own 2 feet. That would be my first, you know, task for the robot. I wouldn't give it a head start. You know, I want it to crawl before it can walk. I don't want it started off by walking. Right? I don't know, I wouldn't teach it to crawl though. I would just teach it to get up and start walking actually. But whatever. You get the point. Alright. Now, where am I going with this? That's a good question. Okay, I was going to look through the GitHub. Let me jump back over to the GitHub. I'm all over the place here. Oh yes, mechanical. Now, if you look at these, let's look at the torso. I don't believe we could actually see these in GitHub. Oh, it's just a step file. So you actually feed this into a CNC machine, and then it actually carves out the robot shape from a piece of metal. And so that's what this is. All right. So I thought these were 3D files, but these are actually just step files for, you know, it's literally just giving the machine directions and telling it how to move the tools around. So that's what you get right here. That's what they open sourced. What is this, off the shelf? Oh yeah, see. This is just this is literally thousands of lines of directions for the CNC machine. All right. So if you look through those, that's what you get in mechanical, but that's where you want to start. Obviously, if you're going to build this yourself, you would need a CNC machine and a 3D printer and a lot of time. And then you still have to, you know, assemble it. You'd have to get all the screws, heat set the screw inserts, um, put all the wires in. That would take a long time too, the wiring. And from what it looks like, all the wires go through the arms, so that's convenient. I actually built an open source robot arm a few years ago, and it didn't have, all the wires were like on the outside of the arm, so it was kind of awkward when it was all built. Had a lot of wires all over the place. But this actually looks pretty clean. And then, so, let's see. I guess let's jump over here. I'll mute this real quick. Actually, leave it on. Yeah, so this is them testing out the robot. Yeah, looks pretty cool. Even though it doesn't have hands, even though that is kind of an important function, hands. Even though it could probably grip things with just the arms. I don't know, I wonder how much can the arms move forward? How much do the arms move forward? Can the arms move like enough to grip a box? That's what I'm talking about. Alright. Getting off track here. Let's check out this DIY kit. I'm still yapping here. Alright, DIY kit. So it's not available yet. Target price 15 grand. 15,000 smackaroos. Wow. Or you can, build it yourself if you have the machinery to do it, and some metal and some filament for your 3D printer. All that stuff. And then, of course, you still need hands. So I'm not sure if this hand attachment, how... Wonder if you can attach something to that, or if you have to customize that yourself also. That's kind of an issue. I wonder if it could pick up a box in the configuration without hands, like the way it is right now. Or you could just put some rubber hands on it or something. That might be enough. Alright. And so here's their website. Some facts. Alright. Oh, so we can hack it, build our own software or hardware on top of it. And it's open source. You could even build these and sell them yourself if you really wanted to. That'd be nice. And then you know what? If I get 100,000 subscribers in the next 30 days, I will actually build one of these and make a video about me building it. And show you and tell you all about it. And then maybe I'll have it sitting here next to me while I'm recording future videos. So yep, if I could get 100,000 subscribers in the next 30 days, then I will build an Asimov robot. Alright. Now, I'm not going to worry about shipping costs because I'll just build it myself. Alright, made in the USA. Except for all the materials that I bought from who knows where. Alright, let's not talk about that though. Alright. Now, where am I even going with this? Alright. Let's try to wrap this up here. Okay, so we've got two paths. The DIY kit, that's $500 to reserve, and $15,000 whenever they finally get around to shipping it in summer. But then you still have to assemble it, and you don't get a battery, a LiDAR, or 4G or 5G modules. But they assure you that everything else you need to assemble the robot would be in the box. So, or you have path 2, and that's self-source. And so you just get the bill of materials, download the repo, print everything out, run it on your CNC machine, cut everything out of raw materials, raw aluminum, and put it together yourself. So that's your second path. But either way, they're saying it's going to cost about 20 grand to do this. So that's quite a bit for a 4-foot tall robot with no hands. Kind of cool, but still pretty expensive. I mean, maybe you can melt down some aluminum cans somehow. I mean, if you have a forge. So if you have a forge, a CNC machine, a 3D printer, then you could probably build this robot yourself. and of course a bunch of tools, a workshop, a garage, a space to actually build this in. So you need a lot of stuff to actually build this on top of the actual investment. So yeah, you can build it yourself, but I mean, I don't know. I don't know. Is it worth it? Maybe. All right. So anyhow, drop a comment. Would you self-source or wait for the kit? I'd love to know what you're planning to build. And if you found this useful, the subscribe button is right there. All right. That's all, folks.